Hi, in this video, let's understand what are normalizing flows and how are they used in generative AI models. Do you know how images, text and videos are generated in AI? Behind those simple outputs, there is actually a powerful mathematic program running. But yeah, the math behind it isn't that simple. So let's get into the topic. Generative AI means creating new data, like generating a photo or a piece of text. Generative models basically try to guess if this is the current phase, how would a future phase look? That's the kind of prediction they make. We have already discussed variational autoencoders, GANs, and transformers. All these models take random data from a high dimensional space and generate outputs from it. So, what does a normalizing flow do? What exactly is it? Think of a flow like a river. It transforms water from one place to another. Simply, in normalizing flows, we transform a simple distribution into a complex one using a series of transformations. Think of it like this: plain rice into biryani. And guess what? You can even go in reverse. Biryani to plain rice. That's the beauty of it. Invertible transformations. These transformations are bijective functions, which means both forward and reverse operations are possible. Let's say we have a Latin variable z and we apply a transformation f of z equal to x. Then x become our complex data. So x equal to function of z, and we can also reverse it as z equal to f inverse of x. To calculate the probability distribution, we use the Jacobian determinant. Yeah, sounds heavy, right? But don't worry, software handles it for us. Imagine Ravi is doing face swapping. He converts a simple face into a stylish one, adds beards, sunglasses, chain, etc. But Ravi can also reverse it. He can turn stylish Ravi back into normal Ravi. That's what an invertible transformation is. In normalizing flows, every transformation steps must be invertible, easy to compute, differentiable. So we start stacking them F1, F2, F3. Each transformation gradually converts a Gaussian into a real-world phase loop. Next, types of normalizing flows plus popular models. Real non-volume preserving splits data into parts and only transforms some of them. Very efficient. Next, GLOW, generative flow, used for realistic image generation with deep reversible architectures. Next, MAF, masked autoregressive flow. It has slow sampling but fast density estimation. Next one, NICE, introduced by Facebook Research, used only volume preserving transformations. Each of these has specific use cases: face generation, music synthesis, even deepfakes. Now, let's connect everything. Applications in generative modeling. It starts with random noise. Apply a series of invertible transformations and get complex output. Use backward transformation for density estimation. These generative models are uses for realistic face generation, music generation, video frame prediction, scientific simulations, language modeling, and many more. Normalizing flows are super useful where exact probability computation is needed, something GANs cannot do. So, to wrap it up, normalizing flows are easy to sample, invertible, provide exact probabilities, and powerful for generative modeling. For more such videos, subscribe to our channel. If you like this video, give it a like and share. And don't forget to drop your doubts in the comments. Thanks for watching.